Thank you for the warm reception of my last video, but I've already got a taker on my questions to content offer. Today, we will be having a look at making a PCB in KiCad to connect different sensors together in a single unified PCB. But what does that offer? So I'm offering to take your questions and turn them into dedicated videos on the channel, code and circuit boards included, no charge. It's a promotion because I'm looking for anything cool I can do. So let's get started making a circuit board. All right, let's throw this away. We are going to cheat off of it. Let's start from scratch. So first things first. So here's our new project. All I've done is name it. I'm going to open up the schematic. Here's a blank schematic. So here's the secret to making boards for Arduino or Raspberry Pi Pico module breakouts. The only symbols we're going to need are generic connector. So the way I search for these is 01X 0406, whatever the number of pins you need is. So I'm going to pick connector 6. I'm going to zoom in on that. What I'll do for this is I actually want to turn it this way. And let's set some info about it. First of all, I'm going to call this U1. It's not exactly correct or incorrect. J1 is for a jumper. Usually when you connect wire pins to something, that's what you would call it. But U1 is like an integrated circuit or a module of some kind. So I'm going to call these U1 to indicate that they're modules, and I'm going to label it. So what is this GYBMP anyway? So here's the module. I don't actually know this module. You'll have to find your own pinout or information for your modules. But what I really want are those labels. So the way I would normally start my schematic in KiCad is by recreating the pin labels that I need. So we'll do that with some power symbols. The two we're going to need are ground and 3.3 volts or 3V3. I'm just going to put them to the side and copy them as I need them. Oh, and by the way, the whole purpose of this PCB is to have two of these. So I'll just copy that now. Control C, Control V. That's the secret. So let's connect these. Where do we need them? So according to that sheet, we're going to have this one and this one. And I'll press R to rotate this just to keep the schematic tidy. It's up to you. You could turn your ground sideways, but I'll just scoot it a little bit. So now that I've got those lined up, I'll just draw a path to connect them. For the rest of these, we have specific purposes, so I'm going to use labels. So let's say SCL. And a label doesn't do anything on its own, but when you have labels that have the same name, they'll be connected together when you go to draw the actual circuit board. SDA for serial data. Whoops. Scoot that guy in. So there's a couple of other pins on this module. CSB and SDO. So SDO I know is going to be no connection. But now that I've got those, I know that these are all going to be identical for the other board. So I'm going to select all of those and paste to just copy them. So now we have two of this module that are wired up exactly the same way. For these CSB pins, I know one of them has to be no connection, and the other one has to be connected to 3.3 volts. So I'll just draw a line there. Grab 3.3. And that seems fine. So now this will be I'm done with those guys. This will be a breakout board. So I'm going to need one more connector, which would be 01x04. I like the generic one. So I'll put this connector here. And now we connect the things that we need on our other pin. This is the pins for the microcontroller. So I'll just wire that. It's up to you how you want to arrange your pins. How does that look? I think this would look better if it scooted over. There, that's a fairly readable schematic. So it might seem weird that this stuff is not actually connected with wires going back and forth between the connectors, but this is actually sufficient because the labels are the same. We know that the things will be connected on the PCB. So this looks okay as is. Now we need to assign footprints. So the footprint is the physical layout of the device. And there's a ton of these things, but what I will look for is pin header. PIN, where? Well, let's have a search. Connector pin header, 2.54 millimeters. That's 1/10 of an inch. And for those modules, I want a 1x6 vertical. I'm just going to copy this text and paste it to the other one. If you assign the footprint before you copy the module, then it'll carry over. Same thing here, but I'm just going to sneak into where it says 6, change that to a 4. There's our connectors. Nothing else to it but to build the PCB itself. So I'll go to Tools and Update PCB from Schematic. It should start it from scratch. Can I update the PCB? Okay, when I hit Updates, I should get these connectors all together. So what I'm going to do, because what I personally like is when the pins on these boards are properly spaced to fit a breadboard. Even if it isn't going on a breadboard directly, it's still nice that the pins are the same spacing apart, just so stuff fits. There's no telling when that might be useful. So I'm going to stack these guys up and drag them all so that they're centered on this 1/10 of an inch grid, 2.54 millimeters. And now I'm going to pick one at a time, one footprint, and drag them. So I know they are grid aligned. I think that's probably enough. And you may have to rotate these. In fact, I think I want to rotate like that. I think that's probably right. Let's see. 2, 3, 4 pins between them. You might be able to get away with as little spacing as like that. And what I would consider more advanced, you might see this pink line around. That is the keep out area that prevents you from putting other parts too close to each other. It'll show red in the latest version of KiCad. It would be nice, I think, to create custom footprints for the modules, but that's like an advanced task. Next, I'm going to go to the layer for front silkscreen. And I'm going to add some text, 3v3. And let's keep adding more labels. Okay, hold on. I think I see a bug in the schematic. Yeah, it says SCL twice. That's not right. Let's update the PCB. Okay, that all looks correct now. The thing that I really want to know though is how big is this module? Okay, I see on the info sheet it's 11.5 by 15. So let's make a rectangle on the silk screen that is 11.5 by 15. So I think it's going to be 15 this way. It would fit in that. So let's take this rectangle. That looks about right. Let's copy it and paste it. So I might have to do some wiggling to get this rectangle to fit, or lower my grid size to about half size grid. That looks good. So as long as I remember to go 2 notches at a time on this grid size, we'll stay the correct spacing apart. 1, 2. Okay, I like that. Now let's copy these labels, because I think it's good to have as many labels as possible on your board. And for the other connections, I might just want to put no connection on those. Oh wait, that one's not. So this one is 3v3. So anything else you can add to your PCB text-wise can be helpful. So I know that if we take the CSB pin and it is connected to VCC, it changes the I2C address. What are those changed addresses? So leave SDO unconnected to get 076 and connect it to 3.3 volts to get 077. So let's add that info directly onto our board. I2C ADDR 0x76. I'm going to add that right up top. I'll do some alignment once I change the grid size, but just getting everything on there is a good start. This one, I'll just change it to say 77. Okay, so we've got all our information. We've got our parts roughly aligned. Now let's make the edge of the board. So go to Edge Cuts, make a rectangle, and make this rectangle have sufficient spacing between all the labels you have and the edge. What did I do wrong? Okay, there we go. Okay, and I think that's good. Honestly, maybe I should move these labels to the inside of the pin, shouldn't I? And then I can make this box just a little bit tighter. And I kind of like that, although that is a little tight. So let me go to half grid and make it just a little bit longer in this direction. And this is also a good time to align my text a little better. And I'm happy with how that looks. But to really make this board a little nicer, right-click the rectangle and hit Fillet Lines. And 2.54 is a fine radius, which gives us a board that looks like that. At this point, we should be able to go to the 3D view and sanity check that the board has kind of the right scope and scale and everything. We're close to done, but we haven't done a single trace on the PCB yet. So what I personally like to do is go to the predefined sizes and give us some options like 0.5, 1, and 1.5. If we needed narrower traces, we could use them, but for a board like this, the copper is already on the board when they go to cut it, so don't leave a bunch of copper in the vat when they dissolve it off. Use big traces. There's no reason not to. You should always use the biggest trace that you can. Really, it's when you get to fine pitch parts that you need narrow traces. And if you have to go narrow for as little as time as you can, like pass between the pins, but then use a wide trace the rest of the way. So let's just pick our trace tool and a copper layer. And I'm going to leave ground out of this, but... Yo, cool editor John here. Cut for time is some trial and error on this circuit layout. So just be aware that it took me about 3 tries to get happy with the way the traces went. I consider it a good challenge to try to avoid using vias if you don't need them. You oftentimes don't, but they don't cost more, so do whatever is easiest. Good luck. Now let's go to the other layer of copper and run the SCL around the inside and the SDA around the back. Okay, I believe this is now complete except for ground, which I've completely blocked off. So let me back up a little more. There's got to be something clever I could do here. Yes, let's take from the front trace. I'm just using the delete key to take this trace away, one little chunk at a time. That looks good. I think we should be ready for the last part, which is ground. So now what I'd like to do is choose a zone, filled zone. So we're going to pick the front layer and connect this to the ground net. So ground, I'm now going to go around the outside of the edges of the board and press B on my keyboard to fill the zone. So now let's have a look at what that did. This red area is now a pour of all the surface of the board. And if we press Alt-3 or view in 3D, we can see that this 3.3 volt trace goes across there, and the ground fill goes from there to there and also to there. Not important for a board like this to use a ground pour, but and honestly I think it was better the last time I tried this, but that is a sufficient way to connect the whole board together. Got a lot of space on this board to slap a QR code or any other helpful info you can think of. So let's add that now. I'll just add text. I want to go for like a larger font, so I'll change the size of it and make it bold and say GY-BMP280 X2. Rotate that around, and I put it on the wrong layer. So let's double click that and pick the silkscreen layer. You can put text in the copper layer, which sure does look cool. And don't forget to put a, revision info. So if you want to put something on the other side of the board, let's just write our text. And what I'll say is, I'm still on the wrong layer. Pick the layer you want to make stuff on, dang. Design by. So there's our text. We're looking at the top of the board, so I'll press F to flip this, and now it is ready to put on the back, which is very hard to read when it's all stacked up like this. So let's look at it in 3D mode. There's our modules, there's our labels. Let's flip this guy over. And there's my info. So I think that's about ready to go. Let's get it ready to be manufactured. So I'll save this and I will go to plots. For the output directory, I always like to pick to make sure I know where I'm going and make a new folder called plots. Now that I have the plot folder, I'm just going to say, do you want to use a relative path? No. All of these checkboxes and options you will have to get with your board house to make sure you pick the right ones. Mine is already set up for JLC PCB. It shouldn't be terribly difficult to figure out which layers you need to include. And what we'll hit is plots, which will create all of these files. It's different layers of your PCB being rendered as a vector image. And I'll hit generate drill files. When I hit that, this creates the separate plotting of where holes need to be drilled in your PCB. So at this point, you can go to that folder, zip up the folder called plots. It's ready to send to your board house to get manufactured, which I'll pull up in a second. But a couple of other things that we could talk about here. It's always nice to run your board through the DRC, the design rules checker. If you hit run, you should see that it has some stuff it's unhappy about, which it will point you to. Mostly it seems like it's mad about lines overlapping on the silk screen, which I don't really care about. Whatever, I think that's all passable. Also, if you needed to, for whatever reason, use a via, which is not something we talked about so far. Let's just say, for example, if you're trying to draw a trace from SCL around here, you can't get over that guy because there's only one layer of copper. It might draw a crazy trace all the way around something if you're trying to do that. So if you needed to, what you can put is a via. I'll put a via here and here. So because these are in a ground pour, they were already assigned to ground. But what I can put is assign them to, was it SCL? And I'll do the same thing to this one, assign it to SCL. So now we've got the rat's nest drawn a path between those things. Now I'm going to draw a trace, and let's do a little one from SCL and switch layers to there. So in this case, a via is a hole through the board that gets drilled that is electroplated and connects the two sides of the board together electrically. If I press B on my keyboard, it will recompute the plane, the ground pour plane, and we can see that it will avoid that connection to keep it isolated. But you shouldn't have to do much in terms of using a via to send a signal to the other side of the board in a very simple board. And what's also very nice about all these through-hole components is the pin connector is itself a via. It's on both sides of the board. You have a nice exposed pad that you can solder to. But what this also means is that we can take a front layer trace to one of these pins and it connects it, and the blue, or the back layer, is connected at all of these points that go through. So at JLC PCB, not sponsored, but call me. So I do need to add my plot to a zip file. Let's go to compress. Now that this is zipped up, I can drag it. Yeah. There's our board, ready for ordering for the excellent sum of $2 to manufacture and $20 to ship. If you'd like to get a PCB design into a group buy, and I'll just send it to you locally over USPS, I'd be happy to help put something like that together. Alrighty, that's all I got. Bye.